Multiply by T2 here, right? What I do on the right, I've got to do on the left. Are we happy? Okay. Then I've got to do what? Divide by P2. So divide here by P2. So let's clean it up a bit and see what we got. We have got V2 will equal T2 P1 V1 over T1 P2. Okay, so we're set. Now we come over here to the table. Right? It's always good to make a table, like on a separate sheet of paper, something, and get your data all figured out. So T2 then is going to be 275.15. P1 is going to be 722. V1 is 1400 divided by T1, 291.15, and P2 is 4. All right. What are we getting? My back row bandits, 275.15 times 722 times 1400 divided by 291.15 divided by 4 equals 238,813 liters. So we went from 1,000 liters, 1,400, to 240,000 liters. Now, does that make sense? I mean, think about it. 22 miles is quite the distance up in the atmosphere. That's one special balloon, right? I think this is about the record for skydiving. All right. Of course, if you go that high, you got to have on oxygen tanks, and I mean, it's freezing to death cold up there, all sorts of things go on. That would be high.
How long will it take you to come back?
What you talking about?
How long will it take you to come back?
The free fall? You could calculate it. I have no clue. I know people calculate that, figure out the terminal velocity, and then figure it out. Military people, like, they do those high altitude, low opening stuff, but it ain't quite that high altitude. That's about to be pretty serious. Okay, so are we good?
I have a quick question.
Okay.
You mentioned that they may give it to us in PSI and we have to convert to millimeters mercury.
Mm-hmm.
How do you convert PSI to millimeters mercury?
All right, give me any pressure you want. You want 35? Is that what's in your tires? All right, so we got 35 PSI here, and she wants to know how to convert that. So what is the conversion? Look there in your chart on chapter 12.
PSI stands for pressure per inch.
Pounds per square inch. So look at your chart, the very first table I put you in, and tell me in 1 atmosphere there would be how many PSI? No. That's 760 torr. 14.7 is the way we go. 14.7 pounds per square inch. What page are you on, Sandy? 269 she's on. That's where she located that. Now, if you need to do it on your test tomorrow, it's on the back page, right? It'll be right there waiting on you. The 760 won't be. You know, that's your problem because you have to only memorize 3. 760 torr, 760 millimeters of mercury, 1 atmosphere. Those are all the same. Those are your most common ones. Now, you want to take it where to torr?
Yeah.
Okay.
No, I wanted to do millimeters mercury, but I didn't know that was going to be given to us on the test.
Oh.
We had those 3 that we memorized, and somehow out of those 3 we had to figure that out.
No. If you needed to do that conversion, and let's do it because I'm on it, you know what I mean. I mean, we're almost there. 35 divided by 14.7 times 760. So to answer her question, that's 1,000 . 809.5 millimeters of mercury. All right. So if her tire gauge read millimeters of mercury, which it don't, she would plug it up, and her thing would read 1,809.5. Okay. How was that? Good? Good for the pressure? Wonderful. So pressure is related to what? Volume. Wow, and then volume, of course, has to be related to moles, and I'll come back to that in a minute. Think about that now. Volume and moles, are they kind of related? How about pressure and moles? I wonder if they can be related. All right, so how do these crazy gas phase chemists operate? All right. Well, you look through a chemistry lab and you'll see beakers and this and that and crucibles and whatnot, but how do we operate as far as gases goes? All right. Well, you have to have a special container, and the container looks like this. This is made out of glass, and this is called a bulb. And inside of that, you're going to put a gas. All right? So that is the thing that you carry around the chemistry building if you're a gas phase chemist. So, how do you get a gas in that piece of glass is the question. All right? And here's how that would be done. You have a vacuum line. All right? And you have a glass blower who makes this for you. This is what mine look like. I even named my vacuum line. You think I'm crazy? Yes? No one's answering. What would you name your vacuum line? You would name it what? Like a dog, after a dog?
No, it's like you started making it some kind of animal.
No, this is all made out of glass. All right, this is a vac line. All right, maybe I'll put that on the test, right? What did I name my vac line? So, well, I don't know. What do you think I named it? What kind of a gas phase guy do you think I am?
I'm guessing you gave her a girlfriend.
I did. Jolene. Julie. No, Jennifer. I named it Jennifer. No, anyway. All right. So I had her name tag up here, Jennifer, and then one day it like blew up and it caught the name tag on fire. So it's still sitting there, this blown up thing. Okay, so Jennifer died. Now, very sad day in my life, right? Okay, so what's going on here is right here is a vacuum, all right, that is pulling in that direction, which means there ain't no air up in here. The pressure is what's called like 10 to the minus 6 torr. You with me? That's 0.00001 torr. Okay? 10 to the minus 6 torr easy is the pressure. So pretty much for all intents and purposes, pressure is 0. You can never have a 0 pressure, but it's close. Okay, so here's what you do. You hook this thing here up to this line like this. Okay. You open it up and you get the pressure inside of this 0. Is everybody happy there ain't no air nowhere? All right, so let's just suppose that I wanted to put a mixture of SO3, nitrogen, and oxygen inside of this container. How would you go about doing that? What's that now?
She said SO3, I said something 8.
And I said no.
No, it's sulfur trioxide. There's no charge here. SO3. Anyway, it's not, okay, we've already been down that road. So the first thing you're going to do is you're going to go find a tank of sulfur trioxide, right? Hook it up to this. All right. And then you will close this. Turn on this tank, and what's going to start to happen? Gas is going to fill up to here, right? Because this is a stopcock, it's closed. So there's going to be gas all in here. Are you happy with that? What's going to happen?